Why have we not caught dark matter yet? Why do we say the universe we see is not real? The universe is far more complex and mysterious than you imagine. We thought we understood the universe, but in reality we might have only seen the tip of the iceberg. Visible matter in the universe accounts for only 5%, the remaining 95% is dark matter and dark energy. 50 years ago, we thought we had mastered the creation formula of the universe, but today we realize we have not even understood the cover of the instruction manual. Even more heartbreaking, the more precise human instruments become, the more they expose a cruel truth. We are essentially blind in the universe. Although telescopes can see through billions of light years, detectors can catch the smallest particles, and computers can simulate the entire universe. The result is that 95% of reality is playing hide-and-seek with us. It is like just buying a magnifying glass only to find you cannot fully see the table in front of you. Or getting new noise-cancelling headphones only to realize you cannot hear the voice of the world at all. Humanity's realization about the proportion of visible matter in the universe started with a mother in the 20th century who simply wanted to observe the stars. In 1970, 41-year-old astronomer Vera Rubin was adjusting the lens of her telescope. This mother of four was not looking for any groundbreaking discovery, she just wanted to solve a long-thought question. How fast do the stars in a galaxy actually move? For years Newton and Kepler had set the rules. The farther the star from the galactic center, the slower it orbits. Just like in the solar system, Mercury is close to the Sun and speeds at 48 km per second. Neptune at the edge moves only at 5 km per second. Vera thought, how do the stars in the Andromeda galaxy, 2.5 million light-years away, move? But when the data popped up, she was astonished to find the stars on the Andromeda's edge were rotating as fast as the stars in the center, both at 300 km per second. This was absurd. According to Newton's laws, at such a high rotational speed the galaxy should have flown apart like a carousel throwing off its passengers. But the Andromeda galaxy has existed stably for billions of years. Vera checked her calculations, remeasured, and even switched to other galaxies. The results were all the same. Vera thought, either Newton was wrong, or there was a powerful, invisible force hiding in the galaxy. She chose the latter. A huge, completely invisible mass was hidden in the universe. But how to confirm this was not just a guess? Simply put, it is like weighing the moon. To know the mass of the Earth, you do not need a scale. Just look at how fast the moon orbits the Earth. The greater the mass, the stronger the gravity, and the faster the moon orbits. Vera used the same method for the galaxies. To stabilize those speeding stars, the total mass of the galaxy had to be 18 times more than the mass of the stars, gas, and dust we can see. In other words, everything we can see accounts for only 5% of the universe. The remaining 95% is all invisible matter. This feels like your house looks 50 square meters, but is actually 1,000 square meters. You can neither see nor touch the extra space, but it is definitely there. To honor astronomer Vera Rubin's huge contribution to observational cosmology, the Vera C. Rubin Observatory, costing $800 million, began construction in Chile in 2015 and is set to release its first cosmic images on June 23, 2025. But what exactly is dark matter? What does it look like? Nobody knows. We only know it does not interact with light. It does not absorb, reflect, or emit light. It is like an invisible man to all electromagnetic waves, so we cannot see it. Yet it is everywhere. In the instant you are watching this video, billions of dark matter particles are passing through your body, through the Earth, through all celestial bodies, like strolling through their own backyard, without saying hello or leaving a trace. They have virtually zero interaction with normal matter except for gravity. To use an analogy, dark matter is like the universe's invisible skeleton. 13.8 billion years ago after the Big Bang, the universe was a uniform fog, with density variations of less than 0.001%. Without dark matter, this fog would never dissipate, let alone form galaxies, stars, and Earth. The real process is likely this. Dark matter built the mold first. Because it does not interact with light, it quickly coalesced into dense halos due to gravity soon after the Big Bang. 380,000 years later, normal matter was finally released from the plasma, pouring into the dark matter scaffolding like water filling a mold, forming the first stars and galaxies. Our Milky Way galaxy is immersed in a dark matter ocean over 200,000 light-years in diameter. This ocean's mass is equivalent to 1 trillion suns. Without this dark matter and dark energy, the stars in the Milky Way would have fled long ago. To put it simply, we are only alive because of this 95% invisible matter upholding us. Since dark matter truly exists and there is so much of it, should not catching a few be a piece of cake? Guess what happened? Humanity has chased it for 50 years and has not even touched a shadow. Because dark matter does not touch anything, leave traces, or make a sound, humans have no way to start. Physicists' method is to wait patiently for it to hit them. So physicists placed a detector called LUX-ZEPLIN, LZ, in South Dakota, USA. It uses 7 tons of liquid xenon cooled to -100 degrees Celsius and is buried 1.5 kilometers deep in an old gold mine, wrapped in 72,000 liters of ultrapure water to block cosmic ray interference. Years passed. Billions of signals were analyzed. Apart from cosmic rays and natural radiation, there was nothing. Dark matter seemed to be saying, "No chance of catching me." But in 2025, good news arrived. Scientists from Switzerland and Israel developed a quantum detector called CARRACK, boosting the sensitivity to 0.011 electron volts, which is thousands of times higher than previous equipment. They froze the detector to 0.1 degrees Celsius above absolute zero, using superconducting nanowires as the target, and actually recorded a suspicious signal. Although it cannot be confirmed as dark matter yet, this is the first time we have touched the threshold of dark matter. Even more amazing, this thing can distinguish direction. Theoretically, dark matter particles might come from a specific direction within the Milky Way. If this can be confirmed, the finding will be solid. However, the research team said the next step is to move the detector deeper underground to completely avoid cosmic rays. Besides waiting for it, others want to actively create it. In Europe's Large Hadron Collider, LHC, protons collide at near-light speed. If dark matter is a type of particle, it should, in theory, be knocked out. But after several collisions, no trace was found. Is dark matter actively avoiding detection, or is the human method incorrect? In March 2025, the Euclid telescope released a cosmic snapshot. It photographed 26 million galaxies, the furthest 10.5 billion light-years from Earth, and found 500 instances of gravitational lensing after its short operational time. Gravitational lensing is where dark matter's gravity bends the light from distant galaxies, forming Einstein rings. Scientists use these lenses to map the 3D distribution of dark matter. It is estimated that by the end of its mission in 2030, Euclid will have photographed 1.5 billion galaxies. At that point, the distribution of dark matter will be impossible to hide. Currently, the focus of the debate is, does dark matter truly exist, or was Einstein wrong? After half a century, some people suspect that perhaps there is no dark matter at all, and our laws of gravity are incorrect. Some believe both might be true. Dark matter exists, and gravity indeed behaves differently on cosmic scales. Maybe we understand neither matter nor space-time. Even more mystifying, Some physicists guess dark matter might be a parallel universe. After all, it accounts for 95%. Why can it not have its own atoms, molecules, even planets, and stars? It is like two film strips overlaid on the same screen, playing their own scenes without interfering with each other. You might be passing through a dark matter planet right now without feeling anything. Of course, this is currently a science fiction level hypothesis, but who knows? Was not the original theory of relativity and the multiverse also once just a guess? In reality, whether dark matter is a particle, new gravity, or a parallel universe, we will likely have an answer within the next 2 decades. If the dark matter particle is truly found, physics will have to be rewritten. Quantum mechanics and dark matter might lead us into a completely new world of physics. If it is still not found, then we may have to overturn existing knowledge and rethink what matter and gravity truly are. Some believe that 95% of the universe's matter is invisible and that humanity will never find it. But this is precisely the most fascinating aspect of science. We thought we understood, only to find it was just the tip of the iceberg. Like when we were kids, we thought the Earth was the center, only to learn it orbits the Sun. We thought the atom was the smallest, only to find the proton and neutron later. Every new discovery is the start of progress. The only thing we can be sure of is that right here, right now, billions of dark matter particles are passing through your phone, your fingers, and your brain.